We've got these different size tiles. So the smallest is 300 by 300. And then we've got 300 by 600. So I'm just going to try and make it twice as long. Then 600 by 600. And finally 600 by 900. Okay, now these numbers are not that easy to deal with. So a little trick you can use is to change the unit. Instead of working in millimeters, we could change it to centimeters, but instead let's let 1 unit, we can just make our own measurement up basically. 1 unit equal 300 millimeters. And suddenly this question becomes a lot simpler because this is just a 1 by 1 square. This is a 2 by 1 rectangle. We've got a 2 by 2 square, and then we've got a 3 by 2 rectangle. So we're trying to fit these together to make a square rather than these other more complicated structures. Okay, so make a note of that. If you've never seen that before, it's okay. We're going to have to just bring it back in at the end for the smaller square by just, sizing it back up and changing it to 300 millimeters, whatever, however many it is, and so on. So I've got these different squares, and now I can work out the area of these squares. So this is going to be sorry, not two, what am I talking about? 1 unit squared here is 1 times 1. This one is 2 units squared. This one is 4, and this one is 6. So because we've got equal numbers of each type of tile, then we can add these up. So in one collection, I don't know what else to call it, collection of 4 tiles, the area is 1 plus 2 plus 4 plus 6, which is equal to 13. So we've got to somehow get a square out of that, and the area of the square must be a multiple of 13. Because when you find the area of a square, it's like 4 times 4 or 5 times 5. So because we're making out of these ones, like it's not like I can get 50 or anything, because I've got to use a whole number amount of tiles. Let me just add that. Of collected tiles. I'm still calling it that. Therefore, the smallest possible area is going to equal 13 squared, or 169 units squared. Now that's all great, but can we make it? Can we actually make this? It's not enough to just say, oh, there we go. You've got to actually show that it can be constructed. So let's have a go. Best to actually make a grid as best you can, 13 by 13, and then fill it in. So we're going to have 13 3 by 2 blocks, and then 13 2 by 2, 13 2 by 1, and finally 13 1 by 1s. Right, I'm going to start by trying to fit the larger rectangles in. It's going to make sense to do that rather than try and fit all the smaller ones in and then hope that the larger ones fit. So here we go. 1, 2, 3, 4, 5, 6, 7, 8. Like you can see, I can put the 2x1s or the 1x1s down here. 9, 10, 11, 12, 13. Done. Right, next 2x2s. Let's just carry it on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right, now the 2x1s can start filling in some of the gaps. 1, 2, 3, 4, 5, 6. We can already see success. 7, 8, 9, 10, 11, 12, 13, which just leaves 13 of these along the bottom row. Definitely think a drawing is best. When I first did it, I tried to kind of make an argument about making increasingly smaller rectangles, like trying to fit all of these in and then a load of these in. But you have to kind of, you do have to kind of interlink them. So I don't think it's that straightforward. So this is the best approach. It is possible. We have a 13 unit by 13 unit square. Now we can bring back our original units of measurement. Remember, 1 unit is equal to 300 millimeters. So the smallest possible square is 13 times 300 millimeters by 13 times 300 millimeters. 13 times 3 is 39, so it's going to be 3,900 millimeters by 3,900 millimeters. Millimeters is a very strange choice. You should have at the very least changed it to centimeters at the start. But this is going to be meters, 3.9 meters by 3.9 meters. So just to recap, we've done this little trick of changing the units of measurement to something much more simple. So we're just working in terms of these basic building blocks rather than these much bigger numbers. That was really helpful. You can do it without, but it's just going to be much more complicated. We then use the fact that there's equal numbers of each. So in a single kind of collection for just using one of each, we'd get an area of 13 units squared. So the area of the square must be a multiple of 13, because if you had one of these collections, it would be 13, two of them would be 26, n of them, it would be 13n. So that's where that came from. And therefore, because a square has the area is going to be a square number, the smallest possible area is going to be 13 squared. That's a theoretical area. We just then need to check that that worked. So we did this construction, which worked out really well. Show that it's possible, change it back into millimeters using this conversion, and change it back into a more sensible unit. Done.